Hello everyone. In this video, we're going to demonstrate the Gauss-Jordan method. Gauss-Jordan method is a modification of Gauss elimination method. The series of operations performed are quite similar to the Gauss elimination method. But in the Gauss elimination method, an upper triangular matrix is derived, while in the Gauss-Jordan method, an identity matrix is derived. Hence, back solution or back substitutions rather are not required. And so our example here is the x minus 2y is equal to negative 4, 5y plus z is equal to negative 9, 4x minus 3z is equal to negative 10. This set of equations will be solved using the said method, the Gauss-Jordan method. So first, let's create the augmented matrix. Here is the augmented matrix. Let's copy this 3 by 3 here will be for the variables. Don't get confused though if here, for example, in the first equation, the z does not exist, therefore it has a value of 0. So it still has a space on the matrix. Then our constants are on the other side. So I hope you remember this because we're going to erase this one to make some room. So here is our augmented matrix, and let's start now the row reduction method. I mean the row reduction technique. So first one is multiplying the first row by negative 4 and adding it to the result, adding it to the R3 rather. So therefore we'll be reducing this. Negative 4 times 1 is negative 4 plus 4 is equal to 0. Then 0, 0, so this is the value. Here is negative 4 times negative 2 is 8 plus 0. This will become 8. And here, so negative 4 times negative 4 is 16 plus 10 is what? This will become 6. Okay. Don't forget, the constant is also affected by the row reduction that we're doing here. So the next part is multiplying the second row by negative 1/5 to reduce this one. So negative 1/5 R2 is 1. And then here, 0. And we're going to get a negative 1/5 here. Also here, negative 1/5 times negative 9. We'll be getting 9/5. So the next part is multiplying the second row and add the result to the first row. So second row, multiply the second row and add the result to the first row. So multiply this by 2, okay? To be clear. So 2 R2 plus R1. So we could vanish this 1, reduce this to 0. This is will become negative 2/5, and this will become also negative 2/5. And then multiplying the second row by negative 8 and add the result to the third row, therefore reducing this into 1. Then this, the negative 8 will be arriving to negative 7 over 5, or negative 7/5. Then here will be negative 42 over 5. So multiplying third row by negative 5 over 7, we will be getting the reduction for this one, or rather we'll get this to 1, sorry. And then this is already reduced to 0. Okay, I'm sorry I've made that error earlier. So this is already reduced to 0, okay? Because we're running out of operations here. Here negative 42 over 5 will be reduced into 6. We're going to um, multiply R3 by 2/5, then add 1, so it's like 2/5 plus negative 2/5 is 0. And here we'll gain 2. Because this 6 is 1, so they have different results. Then here at the second row, we're going to multiply 1/5 from R3, then add to R2. The same concept what we've done above. Then here will also be reduced into 3. So the values now is x is equal to 2, y is equal to 3, and z is equal to 6. These are the values of x, y, and z from the example that are given to us. And at this point, we have just solved it.